Hello, everyone. Welcome on this wonderful Wednesday to our book study webinar, Making Problem Solving the Heart of Math class. We'll be talking about the new Teaching Mathematics Through Problem Solving, featuring co-editor Jody Guarino. And we are very, very excited that she's here. So while you're all coming in, let's go through some icebreakers. Where are you joining us from? What do you teach? What made you want to join this webinar today? And what about this topic interests you? Why did you decide to join us today? I'm so happy you're here, but I'd love to hear why you were excited to be here. And some helpful tips to make the most of your webinar. If you would like to access closed captioning, please hit the CC button in the bottom tray and show subtitles. You can participate and make comments at any time via the chat. We will answer any questions we can while we're rolling, but you can also submit questions using the Q&A function. And whatever time we have left at the end of the presentation, we'll have dedicated Q&A time. And I will hold all your questions until the end for Jody. You will receive a certificate of attendance with your webinar recording via Zoom email in the next 24 hours. And I always do this. If any of you have joined us before, I try to repeat this bullet because I know people are going to ask about 50 more times. But I promise you, if you're attending live, you will receive a certificate of attendance with your webinar recording via Zoom and usually the next 24 hours. But if you haven't received it in 48, please let me know or mail events@amplify.com. And now to introduce our wonderful speaker. Jody is a teacher educator with 2 decades of classroom teaching experience. She's also co-editor of Teaching Mathematics Through Problem Solving. She worked on it with a few of our favorite educators and friends, so we're very excited to see her here today talking about it with us. In her current role as lecturer at the University of California, Irvine School of Education, and as part of the Teaching, Learning, and Instructional Leadership Collaborative at Orange County Department of Education. Jody, that is quite a title. It's such a mouthful. She supports student, teacher, and administrator learning and practice. So I will now kick it over to Jody to get started.
Thank you, Shannon. I am so excited to be with you all today. Let me share my screen. To talk about making problem solving the heart of math class. And I thought I would start today with an analogy that we include in the beginning of teaching mathematics through problem solving. And that's this idea that think about a time when you got a new piece of technology, maybe a new laptop or a new tablet or a new phone. And how did you learn how to use it? So I think about some people jump right in and start tapping and swiping without ever touching the user guide. And then other people read the entire user guide, like cover to cover, before even touching the device. And when I think about this, I think about the majority of people probably use a blend of those two approaches, trying things based on prior knowledge while keeping the guide or Google close by as questions arise. So this toggling between the experience of like jumping in and trying it and explanation being like the user guide sort of epitomizes learning through problem solving. If this is the way that we approach problems in our daily lives, then what does it look like for students to make sense of this in the classrooms that we're working in? So I invite you to take a minute and reflect, where do you think you are on this continuum? Like, are you a person that just starts jumping in and trying things? Or are you like, hold on, let me slow down and find and read the user guide? And where would you say your school or district is? So you might notice this blue icon or blue-green icon that says, let's discuss. So I invite you to put your thoughts in the chat. Where are you? And where do you think your district is? And you'll see that icon throughout our time today. Jump in and try. Tiffany, thank you. And you think your district is there too. Lisa, a blend. And maybe the district is a little bit different than the way you are. Quite a few of us are kind of in the middle. So as I mentioned before, this is how we open the book and really thinking about like, what does it mean for students to be problem solvers? And what does this mean like in life beyond school as well? So I want to talk about this idea that problem solving leads to understanding and think about a situation. Like to me, I'm thinking about a few years ago, I took up gardening. That wasn't something I was interested in before. And when I started gardening for the first time, like I knew I needed seeds, put them in soil, water, and kind of cross my fingers and hope something grows. And I would say my early attempts were kind of random. I just bought whatever was at the nursery the day that I went there. Didn't think twice about what I would plant next to each other or how I would space it out. Um, but then things started to happen. Like at one point, some leaves began to sort of mildew and some bugs started eating things. And I ended up looking for information like, what could be causing this? What can I do? And that's when I was jumping into Google, like these bugs, they look like this. What are they doing, or how do I get rid of them? And as I came to understand more, I think I became more proactive than reactive. Like when the first round of the garden didn't work so well, I started thinking about, well, is there something I could mix in the soil when I plant the garden? Are there regular treatments I could use, or maybe companion plants that would either help things grow or lessen the number of pests? And as I came to understand more, I think I was more intentional in my work. I had more understanding and I was more excited about it because things started to grow. And then, like, oh my gosh, if I can grow this, let me try this other thing. And I think about that with students and understanding. And when we understand things, we're motivated. It promotes more understanding, right? I think about like this filing cabinet. And when I get new information, it's easier to use when I can store it in like an existing file. Like I know something about that versus the things that like it doesn't really connect with anything. And so therefore I think I might lose those ideas. Understanding enhances transfer, which isn't that what we're all about? When students learn things in our classroom that they can apply them to new and different ideas. So I wanted to sort of start with something that we start with chapter 1 in the book, and that problem solving leads us to understanding. So in our time together today, I have three goals. First, to clarify, what does it mean to make problem solving the core of math instruction? And to examine why instruction often tips toward telling too quickly. I know I have done this to like, oh my gosh, I start telling kids things. Well, why am I doing that? And then we're also going to explore a lesson. We're going to look at a lesson, a second grade lesson, and think about, well, how does that lesson center student thinking and center problem solving? So before we get into that, I want to take a minute and think about this question. When students struggle during a math lesson, my instinct is usually to, and I invite you to add a word or a phrase to the chat. How do you respond when students start to struggle? I'm seeing quite a few people ask them questions, maybe scaffold, um, read it again, scaffold with support. I love that scaffold with support. And then I often think about like how much scaffolding or when is that point where I've sort of over scaffolded and maybe ended up doing some of the critical thinking. I love Zach referring to resources around the room, having them draw or use manipulatives, super helpful, acting it out. I've heard of people too changing the numbers and making maybe the numbers more accessible to students and then going back to the larger numbers. Um, check myself to, yes, Kristen, I totally agree with you on that. The thinking and the struggle is so important. And how do we make sure that that struggle is productive? So thank you all for participating. As I think about when students struggle during math, what we do, um, I think the issue isn't whether we should explain to students something that they're grappling with. I think it's about when the explanation supports learning versus replaces it. And sort of this idea of like, sometimes I feel like, did I jump in too soon? Or did my explaining something take away the aha of my students or them deeply grappling with an idea? So I want to talk about like what does it mean to put problem solving at the center and what does that actually look like and sound like? So we talk about problem solving at the heart versus problem solving as an add-on because problem solver, it's not like an opener before real teaching. It's not a reward at the end, but really the place where learning happens. And when we say problem solving, we're is at the heart. We're not talking about adding a rich task like once in a while or like every Friday or ending a lesson with a word problem, which I think is sort of how I grew up. There were like, solve all these problems, and now here's a word problem to sort of consolidate it all. But we think a lot about problem solving should be the primary context in which children learn new math, not something that happens sort of after the teaching. Like you've had all these experiences and now apply it. Like, how do we start with thinking about problem solving as a means to make sense of the mathematical ideas that we're working on with students? So we're going to engage in a poll. And here's what I'm curious about. In your current context, where would you say problem solving most often lives? Is it at the beginning, middle, or end of instruction? So if you go ahead and complete the poll, and Shannon, can you pull up the results of that? Interesting. So some of us in the beginning, a lot in the middle, a few of us at the end. So one of the challenges, I think, like many of us, I think about really like it varies, right? And maybe it makes sense at different points in the lesson. Um, and I think sometimes when we get to the end, like often then we might run out of time or like do students get a chance to really build the understanding for themselves? So we want to think about the teacher's role in this and also what does it look like and what does it sound like? So in a minute, we are going to drop into a classroom to think about what does it mean to center problem solving and for problem solving to be at the heart of the math classroom. So I invite you to take just a minute to think to yourself. Um, 80 divided by 4 is the same as 80 divided by 2 plus 80 divided by 2. So take a minute and just think about this. And that's the lesson we're going to drop into. So I just want to give us a little bit of think time to have thought about the math before we drop into a video. So we are going to drop into a fourth grade classroom. This is the classroom of a teacher named Lynn Simpson at Lake Ridge Elementary School. And while we're watching this video, we're going to watch two clips. The video is a complete lesson or about 30 minutes, but we're just going to watch about 5 minutes of it. And as we're watching, I invite you to think about these two questions, like what opportunities do students have to problem solve within the clip? And how do they engage in the ideas of peers? So I'm going to play both clips and then give you a chance to respond in the chat about these. Like, where do students have opportunities? Like, what opportunities do they have? And how do they engage in ideas in each other's ideas? So here we go.
So here's a new one. Are you ready? True or false? Now remember, if you think it's true or if you think it's false, you want to have a really good reason. Okay? 80 divided by 4 is the same as 80 divided by 2 and 80 divided by 2. I want you to think carefully. 80 divided by 4, I could put a story problem around this. 80 Skittles divided by 4 kids is the same amount as 80 Skittles divided by 2 kids plus 80 Skittles divided by 2 kids. And I think I'm going to have you turn and talk. Remember, you need to have a reason that you think the way you do. Go ahead.
I think it's false. Well,
What are you thinking?
what I was thinking was that 80 divided by 4 equals to 20 because 20 times 4 would equal to 80, and then 80 divided by 2 will equal to 40 because 40 plus 40 equals to 80. So and 40 plus 40 is 80 altogether.
So then what would the final equation read then?
It would be 20 is the same as 40. You think it's true, huh? Yeah, it's false.
So 20, you're saying that the final one would say what? 20 is the same as
40.
and 40 plus 40 is 20 the same as 80.
It's true because if you switch it around, 80 divided by 2 and then it becomes the other two.
So I think that 5 more seconds. As soon as everybody's turned back around. Exciting. I don't think that we're in agreement. Just real quick, show me a thumb if you think it is true. Show me a thumb if you think it is false. So we have some people that think both ways. Would somebody like to defend true? Defend true. Let's start with Jason. Would you defend true?
Because you're cutting in half 4, so it's 80 divided by 2. And then it's another 80 divided by 2 because 2 plus 2 equals 4.
Okay. Adding on to that, Praise?
If you switch it around, it'll be 80 divided by 2, and then it'll be 80 divided by 2 equals 80 divided by 4. And 2 plus 2 equals 4, and then the 80 stays where it is.
Okay. Romy, what are you thinking? You're agreeing.
I think it was true because me and Praise were talking, and all you have to do is add up the 2's, and 2 plus 2 is 4, so then it'll be the same thing.
Okay. Anybody else want to talk about?
So I'm gonna jump in the video and watch one more segment.
Andre, go ahead, Vivian.
I think it's false because if you do 80 divided by 2, then you already splitted all the Skittles, so you can't do it again because all the Skittles are already gone. And you can't change the divisor, you can only change the dividend.
So Jason, you look like you are not sure about what she said. Can you repeat what she said?
Well, she said, like, you can't change the divisor.
Do you remember which one's the divisor?
Yeah, the 4.
Okay. Do you wonder why you can't change the divisor? Should we ask her why?
Mm-hmm.
Why can't you change the divisor?
Because that's how many are in each row, and you can't change that.
Well, and in our story, it's how many kids.
Yeah.
Okay. And what were you saying about the 80 Skittles?
If you split the 80 Skittles between 2 people, and you can't split it again because you already split it all of them.
So what do you think, Jason, about what she said? She said if you split 80 Skittles between two people, you've used them up and you can't do it again. What do you think about that?
I think she might be right, so I'm starting to think it's false.
So you're starting to wonder.
So I invite you now to share in the chat, what opportunities did you notice within those clips? What opportunities do students have to problem solve and or engage in the ideas of peers? So I'm going to actually stop sharing my screen so I can see the chat better. What opportunities do students have to problem solve and engage in the ideas of each other? Sorry, the teacher is acting as facilitator. Lots of turn-in talks, opportunities to share ideas. Everybody has a chance to participate. I love in the beginning of the clip or the first section where everybody was showing their thumbs up or thumbs down, like, do they agree or disagree? So she sort of had a pulse of where students were coming from or just what they thought. She's facilitating without judgment, right? So many great ideas surfaced there, and really her ideas weren't present at all. She was really, oh, I love, Kate, you're saying being respectful and honoring ideas of everyone. They had think time, opportunity to process ideas with each other. Highly inquisitive. There were so many opportunities. I always think about that classroom and I think about, like, what would it be like if all kids felt heard? And I feel like students in that classroom feel heard. Like there's evidence of that when she's asking that question, like, did we help you change your idea? Or how are you thinking about it now? And as they're able to sort of quote each other's ideas, like, well, now that Vivian said that, she's causing me to think about this. So Cynthia, you're noticing like the vocabulary they use to talk about math. Absolutely. Oh, I'm seeing mention of low floor and high ceiling. It seemed like all kids had access to the problem. I also appreciated when she started with the problem at the beginning, it was written numerically, and then she offered that context of Skittles, which seemed really helpful. Like I think about the girl, I think her name was Vivian, where she referenced back to the Skittles, right? Like the Skittles, she said something like the Skittles would already be used up. So also sort of interesting to think about the flow of the entire cycle scaffolds the thinking for the students throughout. Absolutely. I love this video and sharing it. I think there's so much to consider. I love, oh, Darren, you're noticing the real world context. Certainly, like every child has this understanding of sharing something, and like sharing Skittles seems like a really meaningful idea to kids or something that they can access for sure. Talking about thinking, absolutely. So let me go back to sharing my screen here. So as you were watching, right, you noticed students doing like real mathematical work. They were coming up with their own strategies, explaining their thinking, responding to one another's ideas. We saw them not just getting answers, but engaging with ideas, like their own ideas and the ideas of others. And I think this is what we mean by problem solving being the heart at the math class. And it didn't happen by accident. Like I'm sure there was a lot of um, intentionality of that teacher in even creating the community and the space. But what we saw required a teacher who was holding back her own explanations, right? We never saw her insert her ideas. She was also listening closely. Like we saw her leaning in and making sense of what students were saying. And I would offer that I think, again, this is my inference, but that she trusted that students could make progress without being shown the steps first. Like she could have easily just shown them like how to compute it or what to do, but she didn't do that. And I think about the teaching that we saw there takes intention and can also feel risky. Like it might take a lot of time, and will students actually get to the deep understanding that I want them to? Um, and I think moments like the one that we just watched are often hard, right? Hard for us as teachers. Um, but if we believe in learning through problem solving, then how do we support instruction like this versus sometimes instruction often tips toward telling instead? Um, I think sometimes, like I know I've been in situations where what I want is a classroom like that, but I end up telling students, right? It's harder to stay in that space if students feel stuck or if the never ending dilemma of time, right? We never have enough time. So when we're running out of time, does that shift? And then we just sort of tell them. Or maybe we're worried that some kids are going to walk away with being confused. Like I think in that clip, how she really waited or brought, I think his name was Romy, back into the conversation. Like, what do you think now? And I know there's this hesitation often for me when I think about like, okay, it's the end of the math block or this hour, and there's still students that aren't quite convinced. Like, do I feel comfortable leaving them there, or does that feel like, oh, I don't know, like, are they walking away with these misconceptions? But I think it's these moments that create powerful opportunities for problem solving, um, and really create deep mathematical thinkers that I think so many of us want and that our kids deserve. So I wanted to also think about, well, why the balance tips toward telling. And in the next part of our time together, we're going to unpack why that pull toward telling is so strong and why it makes sense, right? Not to judge it, not to eliminate explanation, but to better understand how can we protect space for student thinking before we step in. Because the question isn't, should teachers explain? It's what happens to student thinking when we explain too soon. I think about that paralleled to my garden idea, and someone could have very easily told me like, do this, this, and this when you're planting your garden, and I might have done it right in the moment, but I don't know that it would have created the enduring understanding that I'm thinking about now, based on my own like, oh my gosh, this happened, so I sort of needed to learn and internalize it myself to be able to generalize it more than had someone just said, oh, and when you plant your garden, don't plant these things together and make sure you use this, I don't know, treatment or mix the soil or whatever. So I invite us to think about, well, why does instruction begin to tip? So if you would just take a minute and put in the chat, why do you think, or what have you seen, or what have you experienced um, behind why instruction begins to tip? Oh, awkward silence. Absolutely. We want to help. Oh, this pressure to cover standards, right? To get through the materials, to cover standards. Like um, there's never enough time. Maybe lack of depth of teacher knowledge too. That's a huge one. If I don't know what to do or what the critical ideas are, it's certainly easier to tell students. Oh, this balance between some students got it right away and other students don't have it yet. Like, how do we balance some kids getting bored? Um, Teacher being unsure of what to do next. Absolutely. Old school thinking, right? We grew up this way. This is how I was taught. For sure. Not understanding the conditions for learning. Right. I posed this question because I was thinking about this reality that most classrooms don't tip toward telling because we don't believe in problem solving, right? We believe in problem solving, but we have these like real pressures, right? Telling sometimes feels efficient. Like I don't have a couple days for kids to make sense of this, or um, we have things like pacing guides, like I need to move on to the next unit or the next lesson, right? We worry about students getting frustrated, like maybe they don't want to spend more time on it, or maybe we have this fear of misconceptions. Again, I kind of said this earlier, but we don't want kids to walk away with incomplete understanding. Um, I think also there's this sort of maybe shift from this idea of mastery, where I'm really worried about like, do they need to get this understanding now versus we're going to be in this unit for, weeks, so they have lots of time to develop it. I was thinking about this in the context of volume and thinking about in fifth grade, or at least in my state of California, volume is in fifth grade, and students really understanding this idea of these layers and building on top of area. And how do they construct that understanding themselves versus us coming in with like, here's the formula, it works every time. Um, I think there's a lot of tensions. And how do we sort of come to understand the tensions and even be sort of this litmus test ourselves? So I think that telling often feels efficient, but it can also interrupt sense making. And when we explain too soon, students may get answers, but we lose access to how they're thinking, what they understand, and what they're ready for next. So there's like all of these other implications. So I want to shift now to this idea of seeing the ideas in practice and a lesson snapshot. So I've been working with some teachers that are trying on problem-based learning, or they have been trying it on for the last 2 years, and really thinking about like, what is it in instructional materials that support students to sense make, that are built into the design of the materials, but also the ways in which we enact them. So what we're going to do in just a second, I'm going to drop this lesson into the chat. This lesson comes from Amplify. It's a second grade lesson in um, Unit 2, so toward the beginning of the year, like the second month of school. And it's called Subtracting Your Way. And what you see on the image on the slide is sort of the lesson overview, or what I'm calling the lesson overview. So when I drop the lesson into the chat, I invite you to read the lesson overview. And the way the materials are organized, there's this lesson overview. And then if you scroll down in the PDF, you'll see there's activity 1 and activity 2. So what I invite you to do is consider when, where, and how students problem solve. So I'm going to stop sharing my screen and drop into the chat the lesson and give you a few minutes to look at it. Again, the overview, activity 1 and activity 2. So maybe we'll take about 3 or 4 minutes for private think time, and then we'll come back together and talk about some of the things that you noticed. Thank you all. Let me try that again. It should be a PDF that you can download. I just shared it also in Drive if that might give some people access as well. So I realize some people have had more time than others, depending on when you were able to access the lesson. Um, but I want to think of, even from the lesson overview, some things like students subtract using any strategy that's built into the lesson. Tools are introduced to support student thinking. There's no named procedure up front. So it's not like, oh, we're all going to solve it this way. And this idea that decomposition was intentionally delayed. So early in the lesson, students solve problems mentally, they share multiple strategies, and there's not one right way to solve the problem or one right method, but the teacher honors and records different ways of thinking. So I'm curious, where else do you see students doing the mathematical work here in this lesson? So maybe you could put your thoughts in the chat. Where are students doing the heavy lifting? Okay, just starting right away at the warm-up. Absolutely. The relationships between the problems in the warm-up. The math talk, the show what you know. Right? Students are deciding how to approach the problem. They decide what to use and how to explain their thinking. And later students represent their thinking using the tools. So they start off representing or solving it in any way, and then they're asked to like show your strategy with the connecting cubes or show your strategy with base 10 blocks. What they're not asked to do is follow steps, right? But to make sense of what they did once they use the tools, which feels very different than some more traditional materials or even the way that I learned growing up. It was like, okay, use these tools to do this thing if we even had tools. So I want to think about what the teacher is teaching students to do in this lesson and thinking about these ideas that the teacher is teaching students to compare representations, right? What does that look like when I'm using connecting cubes versus base 10 blocks? The teacher is also inviting students to learn about and think about structure, like the structure in the number system, the structure of the connections of a written method to a visual representation. The teacher is also asking students to explain and justify their thinking. And when I think about all these things together, like this is instruction, like all of the things that the students are doing and the teacher's facilitating. So I think a lot about without centering problem solving, like we think about where's the teaching, but now it's like, okay, the teaching is coming in a different spot. It just looks a little bit different, but it's still there. Think about all the things that students have access to within this lesson. And I want to think about the balance of when explicit teaching matters most. So thinking about like problem-based materials or problem solving where students first solve the problem, right? And then we're connecting strategies, sort of what we saw in the second grade lesson. And then we're informing intentionally and at the right moment. Like making problem solving central doesn't mean never telling or never explaining. Instead, it asks us to think about this sequence, right? Students solve, we make connections or support them to make connections, and then apply it to next ideas. So in this lesson, right, students didn't start by decomposing a 10 yet. That idea came later when they were ready for it, like they'd grappled and they'd had some time to make sense. So when I think about this idea of making problem solving the heart of math class, it doesn't mean, right, less structure. It doesn't mean that. It doesn't mean less clarity. It doesn't mean less teaching. What it does mean is designing problems that carry the mathematics, where students are learning the math and the math ideas through problem solving. It means listening closely to student thinking. So we have a whole chapter in the book that's really about how do we come to listen and make sense of students' thinking. And I think that is one example that we saw in the video of that teacher, Lynn Simpson, really listening carefully and closely to her students. And teaching in response to that, teaching in response to what students know and understand and what they're thinking, not in advance of that. So thank you all for hearing a little bit about some of the key ideas that we were thinking about when we wrote the book together. I'm going to stop sharing my screen and turn it back over to Shannon.
Wow. All right. And I will start sharing mine. Okay, so every time I say that there's not a lot of questions, everyone throws them in the chat immediately. So I'm just waiting for that to happen. But until that happens, we did get a few specifically about the video you shared. Someone was wondering if it was from an Amplify lesson, this question, and what were the learning objectives?
So that is a good question. It's actually it's a video on YouTube from a number talk not related to Amplify, and I don't actually even know what materials, just a really amazing video on YouTube of great teaching and learning as an example.
And another one, which I did share to the person, which I'll also share here, some things I thought would help, but they said these kids are so kind to each other's different ways of thinking, and how can teachers set up their classroom for this level of respect? I know math routines are a very good way to start establishing these kinds of positive outcomes, and anything that setting classroom norms and making everyone feel like it's a collaborative community. But I didn't know if you had any tips also, Jody.
Yeah, what I've seen a lot of teachers do is actually narrate, like at the beginning of the school year when students are starting to move to use these moves. Like there's one, I don't think we saw it in the clip, but I've seen it in a lot of classrooms where students are using, I believe it's sign language, like I agree and symbol signals like that. And I
Mm-hmm.
think about that, like if I share an idea and all of my classmates are going like, I agree, like I think about how that would make me feel of like, oh, I've been heard, like they're actually listening to me, or like it helps me feel confident that other people have an idea similar to mine. So I
Mm-hmm.
think some slight moves like that can be really helpful in creating a community and opening space. The other thing I think about, both with the teacher in that video and teachers that I've seen, when we really like intently listen to kids, then I think they get this idea that like that's how our classrooms are supposed to be. And if I
Mm-hmm.
care enough about your idea, Shannon, that I'm going to listen to it, like we're modeling that for our students. Like your ideas are valued and we care. And this is like this community where we all listen to each other. And I think, as you mentioned, Shannon, like routines are a great way to do that.
Yeah, I mean, students really are, all young kids are sponges, and they really do notice how we act with other people, and they model that all the time. So I think it's a good thing to remember. Let's see. We had some other questions. There are a couple for tier three math students. Someone asked, my tier three math students struggle with abstract thinking. They are uncomfortable and lack confidence when they have freedom to explore math concepts. I break down problem solving into steps and provide math manipulatives. Are there any other suggestions you have to help these kids? I know it's a very big, loaded question.
Yeah, I think the tools are so critical. I'm a parent of two children with IEPs and thought a lot about that when my kids were growing up and like, how do I
Mhm.
give them? And I think for some kids, it's even more of a challenge because it takes them more time. But how
Yeah.
do we give them that gift of time to really like make sense and grapple? I think another way to do that is actually giving them access to other kids' ideas. So I know often, like sometimes my kids would get pulled out or removed from other kids, and they were losing
Hmm.
out on the way other kids thought almost because they needed to develop particular skills. So I think giving them access to other kids' ideas,
Yeah.
connecting representations to what's happening. I think the
Hmm.
video was a beautiful example of right this context of Skittles with just this number equation that could be really confusing, but like maybe adding in context that's going to be meaningful for kids to make sense of like what do those numbers mean? Like I
Yeah.
can think about 80 Skittles far greater than going like the Skittles have already been split. Like such a nice
Yeah, no, I agree. I have
example.
a younger brother with autism who also had an IEP. So, yeah, and got removed frequently from class, which was just really not helpful when he's trying to learn how to behave in situations. Um, and
Absolutely.
then I'll just answer these questions live, even though I can answer them. Can we get a copy of these slides? Christy, you will get all the resources. I've already made a copy of the slides. So you'll get the resources recording and a copy of the slides within the next 24 to 40 hours from the math team at Amplify will be the name in your inbox. So, and same, Lisa, for you. You can absolutely share things from this presentation, including the sample lesson with your students. Lisa is a college professor preparing teachers for the classroom. Jody, so I know you can relate with that. Um,
Yes.
so we will definitely send you all the things, Lisa. Let me see if there are any other questions from the chat. There's just a lot of compliments, which is so nice. Thank you guys so much for joining us. I don't see any questions, so I'm going to flip ahead to the next one. I've put lots of links in here for everyone. Um, If you want to join our next session, it is an introduction to Amplify Desmos Math, where a lot of the ideas from this book, really, you can see them come to life in a real curriculum. We have a structured approach to problem-based learning, so it is pretty much everything in this book really resonates in our curriculum that is only a couple years old. So I would highly recommend checking that out. Learn more about the book and order your copy at nctm.org/problem solving. Access free math activities used tomorrow at amplify.com/classroom. We also have literacy and science activities if you're a K-5 teacher. And you can find more resources on problem-based learning specifically in our problem-based learning starter pack, which we had worked on with Kristen Gray last fall. So it's got a lot of good stuff in there. And then we are already gearing up for Pi Day, everybody. Get ready. Amplify.com/Pi Day. You can find our 2026 bundle of resources and activities. And I'll drop those in the chat right now. But thank you so much, everyone, for joining. Thank you so much, Jody. It has been a pleasure, as always, to talk to you.
Thank you.
That's it. Everyone have a wonderful evening.
Thank you all.